stop me if for some reason something doesn't make sense, and I will try to explain it as best as I can. All right, so when you see this right here, guys, the cosine to the -1, that means there's two ways of saying it. You could either say inverse cosine or you can say arc cosine. Now that's similar to when you see this. F of -1, that means inverse of f, right? So that's all it means. Inverse cosine or arc cosine. It does not mean reciprocal. It means inverse. So what exactly does this mean? Well, it means this. Cosine of one angle, or radian, well, they're both the same, I guess, is a half. Now, hopefully by now, we have reached a point where you guys know what those answers are. On the unit circle, well, first and foremost, cosine is a half. It just means cosine itself is just a ratio, right? Jason over hypotenuse. But if we're talking specifically about the unit circle, guys, it means at what angle is cosine a half? And hopefully, without much thinking, you can tell me that answer is 60 degrees and 300 degrees. But those aren't the only two answers. It goes on forever. So if I were to tell you, so I guess you can say, well, Chavez, you have two general equations or expressions. If I'm in degree mode, you would say 60 degrees plus 360n. That's theta 1. And theta 2, what's the other one? 300 plus 360n. And that will give me all of them. In case you don't understand where the 360n is coming from, it's this, guys. If I do a whole, let's say I'm right here on the green one, and I do a whole revolution like that, isn't that another 360? Yeah, so that's where the 360n is coming from, where n is an integer. It's just how many times I've rotated. 1, 2, 3. There's no such thing as n being a half. N has to be an integer. Does that make sense to everyone? Okay. What's up, miss? 300. At 300 degrees, cosine is also a half. Now, if you look down here, you will see a plus minus in front of the arc cosine. I don't want you to be a robot. There's a reason why there's a plus minus in the front. The reason why that plus minus is in the front is because your calculator is stupid. And I don't mean it like literally, because we program it. All right, so Chavez, what are you talking about? Here's my calculator. It's in radian mode. I'm going to change it to degree mode temporarily, because you guys seem to understand better with degrees here. Okay. So if I tell the calculator arc cosine a half, it's only going to give me one of them. If I go second arc cosine 0.5, 0.5, enter. And see how you just get the 60? And no matter how many times I push arc cosine of 0.5, it's always going to give me the 60. So I can see how I can get this general expression, theta 1. 60 plus 360n will always give me that 0.5. But the calculator will never spit out that 300. So why is that plus minus there? Well, think about it, guys. If I do this, do you guys see this angle in blue? Isn't that angle in blue negative 60 degrees? Yeah. So if I do cosine if I do cosine of negative 60, notice that I put cosine and not arc cosine. That better be 0.5. And check it out, it's 0.5. So how do you get the 300? Well, if I do plus minus, if I do the negative 60 and I add 360 to it, OMG, look at that. You get your 300. Do you guys see that? So this plus minus comes from the fact that the positive and the negative angle will both give you that half. Does that make sense to everyone? Okay. Now, in the future, guys, if it's a perfect coordinate on the unit circle, meaning it's a half, a square root of 3 over 2, or a square root of 2 over 2, you do not have to use formulas. If it's a coordinate that is not perfect, go ahead and use formulas. Cool or not cool? Okay, I think we got the concept of it. We will see right now. So here are some formulas. If you're in degree mode, use the one that has 360n. This is degree. In your radian mode, use the one that has a 2 pi n. Radian. Radians and degrees are both angles, guys. One revolution is 360 degrees. One revolution is 2 pi radians. Are we still okay? All right. I'm going to go slow. It says, find the first 5 positive values of arc cosine half. Notice it says radians. I'm going to draw a unit circle. And I want the first 5 values where arc cosine is 0.5. Remember what this means. That means where cosine of what angle is a half. And I'm in radians. I'm going to go ahead and do 2 equations, general equations. Which one's the first one that I hit? Pi over what? I heard someone say it. Pi over 3. And I'm going to write plus 2 pi n, because those will always give me those terminal angles where the x-coordinate is a half. Does that make sense to everyone? Okay. Theta 2. What's the other angle? This one here in green. Perfect. 5 pi over 3, and I'm going to write plus 2 pi n. Do you guys agree that those will give me all the angles, all of them, where the cosine is a half? Yes, they will give you all of them, infinitely. You can say n is positive integer or n is a negative integer, or n is any integer. N is any integer. If you were taking a class called number theory, you have to give all the rules explicitly. We're not in number theory, so we don't really care about being too specific, but n is an integer. All right, here we go. They want the first 5 positive values. So I'm going to write theta equals. The very first one comes from theta 1, pi over 3, comma. The very next one, and I'll put it here where they're coming from, number 1. The very next one comes from theta 2, 5 pi over 3, comma. The next one after that comes from theta 1. So take your pi over 3. I'm going to go here to the side. Pi over 3. Well, I better not mix mass colors here because I don't want you guys to. Pi over 3, and I'm going to add 2 pi. When I add 2 pi, bless you. When I add 2 pi, put a 3 in the bottom, put a 6 in the top. 6 divided by 3 is 2, right? All I did was common denominator, guys. What is 6 pi plus pi? So that's the next one, 7 pi over 3. The fourth one is going to come from theta 2. So you're going to... No, you're good, miss, you're good. You're doing the same thing, guys. 5 pi over 3 and add your 2 pi, so 6 pi over 3. So 5 pi plus 6 pi is? Perfect. And then your last one is going to come from theta 1. You don't have to start at pi over 3 and add 4 pi. You can. Just go to 7 pi over 3, guys. 7 pi over 3 and add 2 pi. 7 plus 6. So 13 pi over 3. There it is. The first 5 positive values of theta. How do we feel? What's up? The 7 pi over 3, I got it from pi over 3. I added 2 pi. So this one plus 2 pi gave me this one. And then the 5 pi over 3 plus 2 pi gave me the 11 pi over 3. And then the 13 pi over 3 came from the 7 pi over 3, added 2 pi. Or you can say pi over 3 plus 4 pi, but it doesn't matter. I just added 2 pi. So common denominator is 6 over 3. So 6 plus 1 is 7. Okay. Cool? Okay. All right. Here we go. I'm asking the same question on the next page, but is that, I guess they're all perfect coordinates. It is on the unit circle, but is that one of my right triangle perfect coordinates? Half, square root of 3 over 2, square root of 2 over 2? No. So on this one, it's okay to use your formula. So what is your formula? So I'm going to write theta equals, and it says arc cosine of negative 0.3, so I guess I'll write it off for now. And then I'm going to write equals, and now I'm going to put plus minus in the front. I'm going to put arc cosine, or inverse cosine, negative 0.3 plus 2 pi n. Because if I go plus 2 pi, I'm in the same x coordinate. Does that make sense to everyone, guys? Okay, don't worry, I'm going to go slow. I have 2 equations here, the plus and the minus. So here's theta 1. I'm going to take my calculator, and I'm going to go arc cosine. I'm in radians, right? Mode radians. We're going to have a decimal, guys. And I'm going to go arc cosine, so second arc cosine, and I'm going to put negative 0.3. Oh, too many negatives. Delete. And I got that number. Do you guys know how to store numbers in the calculator? Okay, let's teach you guys. Use technology. It's to your benefit, guys. If you want to store, it works the same way for any calculator. Just go look for the instructions for memory or Google it. If I want to store something to a letter here or a register, they call them registers in programming. You push a button, and this one is called STO. So I push STO, store, and notice it says A and S, and then it's telling me where do I want to store it. And I'm going to go alpha A. And when I push enter, every time I push the letter A, it's going to give me that number. Alpha A, enter. See, so now my A is always going to be 1.8754. Cool? Okay, so here we go. So theta 1 is 1.8754 plus 2 pi n. I don't know if I rounded it or truncated. Let me look at it again. 8754. Okay, that's truncated. If you don't, in case, well, okay, I'm sure you guys know, but in case you don't, truncated means whatever that digit is, you just leave it. And then rounded means you would round it, right? So whenever you get a chance, when you have wins for physics or something, like, Mr. Winners, do you want us to truncate or round? And then see what he says. Anyways, theta 2, instead of the positive one, you're going to write the negative one. Negative 1.8754 plus 2 pi n. Are we still okay, guys? What's up? Oh, yeah, because of the plus minus. All right, I'm going to get my answers. They wanted the first what? 5 positive. So here are my final answers. Theta equals, the very first one I see is, well, that one right there, 1.8754, comma. The next one is going to come from theta 2, so I'll tell you where they're coming from. So I'm going to write negative 1.8754 plus 2 pi. So on your calculator, I'm just going to go negative A plus 2 pi. See, like that. Enter. So 4.4076, that's truncated. If you round it, it's 408. 4076. 4.4076, comma. Then the next one's going to come from number 1, or theta 1. So 1.8754 plus 2 pi. So I'm just going to go back and push alpha A plus 2 pi. And then 8.1586. 8.1586, comma. Then the next one, 1, 2, 3, 4, is going to come from the 4.407. And you can call out your A if you want, but look, you can just scroll up on this thing. Up, up, up. 4.407, enter, plus 2 pi. Well, I guess with that feature that you can scroll up, I guess you didn't have to store it. 10.6908. 10.6908. And then finally, the last one comes from the 8.1586 plus 2 pi. So scroll to the 8.1586 plus 2 pi. And there it is, 14.4418. 14.4418. How do we feel? Okay. I want to try to do some vertical alignment, and I want to use some of your Algebra 2 skills. Is there another way to do this question? So hopefully when you were, or maybe in Algebra 1, maybe they taught you this. Didn't they teach you in Algebra 1 and Algebra 2 that you can figure out like answers like for a system of equations by like graphing them and seeing where they intersect? And I know I don't have a system here of an equation, but we know what this means. What does that mean? It means where is cosine equal to negative 0.3. That's what it means, right? So an Algebra 1 skill or an Algebra 2 skill, you can type this one into y1 and type this into y2, or f of 1, f of 2 if you have an Inspire. And then see where they intersect, and wherever they intersect, those are my answers, right? So let's see if we get these exact same answers with that skill. So I'm going to, you don't have to do this. Well, I guess you can if you want to experience it. So click on y equals if you have an 84. If you have an Inspire, you're going to have to go to the drop down, add calculator, or F1, whatever. On Y1, I'm going to type in cosine X. See? On y2, guess what I'm going to type in y2? Negative 0.3. Don't push graph yet because it's going to have your standard window. Remember that cosine just had an amplitude is 1, so it's going to go between negative 1 and 1, right? I'm going to click on window. X min, I want the first 5 positive, so I'm going to go 0. And X max, I'm going to put, let's see, 2, 4, 5 pi. Y min, well, I don't have to go all the way to negative 10. I'm just going to go negative 1. And then Y max, 0. And I don't really care about the Y scale. So check it out. I'm going to push graph. It's going to do it real fast because it's a fast processor. So those are my first 5 answers right there. 1, 2, 3, 4, 5, where they intersect. Now let's see, is there a way to tell the calculator to find intersections? Yes. If you have an 84, by the way, I prefer 84 over Inspire because of speed. I just can't with the drop-down menus. It's easy to do with the Inspire. It's just the drop-down menu slows me down. So you see in blue, at least on this one, it says CALC. That stands for calculate. So any type of machine has something like this. So it's a machine. I want to calculate something. So I'm going to go second, calculate. And here are my options that this calculator can do. Which one is the one that looks like it will be most interesting to me? The one that says intersect. 5. And it's telling me first curve. Well, I only have 2 curves in there. And it's telling me first curve, the one in the blue, yes. Second curve, the one in the red, yes. Guess. When it says guess, there's multiple intersections. And it's telling you which one do you want me to find. So they should use a better word than guess. They should say which one. So I'm going to scroll all the way to the one way over here. And I'm going to push enter. And there it is. It's going to say the word intersection. And it says 1.8754. Is that what my first value was? Perfect. Let's go again. Let's do it again to practice. Second, calculate. Number 5. Enter, enter. Guess. I want the second one over here. I'm going to push enter. Is my second one 4.407? There it is. Let's do one more. Second, calculate. Number 5. Enter, enter. And I'm going to do the last one way out there. So is my fifth one, let's go all the way over here. There you are. There I am. Enter. Is the fifth one 14.44186? There it is. Do you see how we did it, guys? So you have a very powerful machine. Let's try to take advantage of it, guys. All right. Okay. Now we're ready for the last question. I need your A game on this one. So don't worry. When I made these notes, I made them in such a way that I had an idea of how I wanted it to flow in my brain. So the very first question I ask you is, solve with a calculator 7 cosine 2 pi over 13 x minus 4 plus 9 equals 5 on the interval negative 7 to 27. So I knew that I was going to be doing the calculator question, like I was going to tell you, like, don't do it with calculator. So now, can we do the same thing that we just did, but with this one? Yeah. Type this into y1. So go for it, guys. Do that and type that into y2. Be careful. I'll do it too, guys. So y equals clear. I already forgot. 7 cosine. 7 cosine 2 pi over 13. Open parenthesis. X. The x is next to the alpha key. Minus 4 close plus 9. I think I got it right. We may check 7 cosine 2 pi over 13 x minus 4 close plus 9. 7 cosine 2 pi over 13 x minus 4 close plus 9. Yeah, I think that's correct. And then on y2 I'm going to type in 5. Okay, now we got to learn how to use the window. All right, you guys ready? I haven't pushed graph yet because we need to know how to fix the window. So on this one, this means that your domain is specifically between negative 7 and 27. That epsilon there, that E there stands for X is within negative 7 to 27. It's part of a set theory. We're still okay? X min, negative 7. X max, what's the biggest X value I want? 27. X scale doesn't matter. You want to go by ones, you want to go by fives, it doesn't matter. Y min, okay. So look at this graph right here. The midline is 9, and the amplitude is 7. So y min, 9 minus 7 is 2. So you usually want to go a little below that. So I'm going to say y min 0. Y max. Well, the midline is 9, and I go up 7. So that's going to go to 16. And I like to go a little above that. So 18. And then y scale, whatever you want it to be. It doesn't matter. So there it is. I'm going to click on window. So don't push graph yet. Click on window. And I'm going to put that window to that. -7 to, what was it, 27? Don't worry, we're almost done, guys. Y min 0. And y max, was it 18 or 20? 18. Y scale doesn't really matter. You can make the scale whatever. Don't mess with the resolution or your delta x. You can, if you want, experiment with it, but don't mess with it. Push graph, there it is, and there it is. I'm going to get all those intersections. 1, 2, 3, 4, 5, 6. There are 6 of them. I'm going to get the first 3. You guys get the last 3. Second, calculate, number 5. Enter, enter. And then scroll all the way. So here's the first one. -4.4915. X equals -4.4915, comma. Here's the next one. Make sure it says the word intersection. Second, calculate, number 5. Enter, enter. -0.508469. -0.508469, comma. Second, calculate, 5. Enter, enter. 8.5084688. 8.508. 8.508. What's up? Comma. Give me the last 3, guys. Alright, let's see. Make sure we know how to do that, guys. Abdul Kareem, help me out. Give me the 4th one.
I think I got it. Now that I have it,
It sounds like it. 12 point what? 12 point. 4915. Yeah, that sounds correct to me. What's the next one after that? Second, calculate, enter, enter, guess, scroll to it, push enter again. 9361. Okay, let's see. Perfect. What'd you get, Lopez? Yeah, that's the one. All right, guys, let me do this one more time. Ready? Second, calculate number 5. And then it's going to say first curve, yes. Second curve, yes. You only have 2 curves in there. And then when you want the one you want, go to the one you want and push enter, and then it'll do it. It'll say, you got to see the word intersection. 21.508469. There. So there's one more, the one on the far right. Which one's that one? No, it should be exact. Did it say the word intersection? Yeah, push enter. Four, 915. Yep, that sounds correct. There should be 6 answers, guys. Can you help her out a little bit? You got it, right? Yeah. For Christmas, guys, tell your parents to get you a TI-84CE, one of these.
I have one, but I don't know where it is.
You can also get the Inspire. If you want speed, though, you can get so fast with this. See, just look at the difference for graphing. On TI-84, you just push a button, Y equals, bam, you're there. On the TI Inspire, you gotta go through a drop-down menu, add graphing, enter, and then F1 of X equals. It can be done. I just feel like it takes precious seconds away. On this, Y equals, boom, done, enter your graph. So if you value speed over fanciness, I would get this. The TI Inspire has a faster process or stronger processor. It's a more advanced calculator. But for speed, this is better. So for speed, I always like this one better. What's up? The CAS is not, they're probably not going to let you use that. On the SAT, you can. But if you're thinking about college, the CAS, they probably won't let you use it for exams. Professors are, especially, they all have doctorates. They all know about CAS calculators. They're not going to let you use that because that pretty much does the whole exam for you. Any other questions, guys? Sorry. All right, there it is. That's how you do it. But here's the fun part. So I need your A game on this. It worked really awesome the last 2 days, or yesterday. I do 2 steps, and you guys just listen and see and observe if it makes sense, and then you write, and then I do another step, and then you write, and then one other step, and then you write. Sometimes I do 1 step, sometimes I do 2 steps. So can we do that? All right. So here we go. Where it says find algebraically the 6 values of x in example 3. So start by writing this expression again. So I'm going to write 7 cosine 2 pi over 13 x minus 4 close plus 9 equals 5. So write that. As a side note, who can tell me the period of this function on the left? Perfect. Thank you, miss. The period is 13.
Why isn't it 1 over 13?
Oh, okay. So let's say we do the definition, right? So period equals 2 pi divided by the b, and the b is 2 pi. So 2 pi divided by 2 pi over 13, keep, change, flip. 2 pi times 13 over 2 pi. The 2 pi's cancel out, you just get 13. See it? All right. That's just a side note. Keep that in the back of your brain. So you'll see something in a little bit. What's up? Oh, all I did was I just did the b value, because this is the b value, right? So to get the period, it's 2 pi divided by b. And when you do 2 pi over 13, the 2 pi's cancel out, and you just get 13. All right, here we go. The whole point of this is that you want to solve for x. So it might get kind of crazy, but not like crazy as in like stuff going down. But hopefully you'll get it. Cool? I'm going to go real slow, guys. As slow as I can. Here we go. First thing you do. I'm trying to solve for x. I need to get rid of that 9. How do I get rid of the 9? Subtract. So that's the first move I'm going to do. Minus 9, minus 9. So 7 cosine 2 pi over 13 x minus 4 close equals, the difference between 5 and 9 is 4. And it's going to be a negative because the 9 is larger than the 5. Are we okay up to there? All right. Next, I'm still trying to solve for x, but you can't solve for x with that 7 in the front of cosine. So how do I get rid of that 7? Divide. Divide by 7. Divide by 7. Now some of you are doing a line that transcends or keeps going after the equal sign. Stop with that habit, guys. Stop it there. Stop it there. You will lose a point on the AP exam if you keep that line all the way. Everything stops at the equal sign. Cosine 2 pi over 13 x minus 4 close equals negative 4, 7. So catch up to there, guys.
Okay.
What's up?
So what if you don't like put you don't feel like
Oh, if you just go to the next one, like you go from this line to this line?
Kind of just like skip stuff, except
No.
for this stuff.
You didn't skip anything. You showed this line, and then you went right to this. You're fine. Yeah, all these professors and teachers have doctorates. They're not going to be like treating divide by 7. Like, no, you divide by 7. Are we still okay, guys? All right. Next, I want to get rid of the cosine. This is not cosine times blah, blah, blah. Cosine is never by itself. This stuff is called the argument inside. It's like f of x. So how do I get rid of the cosine? I got it. Inverse. Perfect. So do inverse cosine. So write 2 pi over 13, x minus 4 equals, and because we're doing inverse cosine, what am I going to do in the front? Do you guys remember? Well, arc, but there's a sign. Plus or minus. That's what I wanted to hear. Plus minus arc cosine negative 4/7 plus 2 pi n. Are we still okay, guys? Okay. Next, I want to get rid of the 2 pi over 13. So to get rid of it, you can say divide by 2 pi over 13, but what's better? Multiply by the reciprocal. Perfect. So I'm going to multiply by 13 over 2 pi. Whatever you do to one side, you do to the other. So here's how it's going to look. It's going to say x minus 4. You can drop the parentheses now because there's nothing in front of it. And I'm going to go ahead and distribute this. When you distribute it, put it right next to the cosine like this, arc cosine. 13 over 2 pi arc cosine of negative 4/7 plus, when you're distributing 13 over 2 pi times 2 pi n, the 2 pi's cancel out and you just get 13n. Now, as soon as you see this 13n, are you shocked that this is repeating every 13?
Yeah.
Oh, you are?
Well, I mean, not really. Oh, the period.
What's the period? So I am not shocked that this is repeating every 13 because the period is 13. Do you see how it's all connected? Are we good? Okay. We're almost done. So let me show you guys a little secret. What's up?
Okay, so whenever you put 13 over 2 pi at the beginning, was the 13 over 2 pi or was 2 pi times 1 so
Yeah. That 2 pi.
was the thing that's in front of the number?
No, the thing on the front is there. There's a plus right here, miss. You got to distribute it to both. Whenever you have a times b plus c, you go a times b, so ab plus ac, right? Okay. Bless you. All right. Here we go, guys. So this is probably the most important step. A lot of you have a tendency to get x by itself by going plus 4, and you put plus 4 on this other side, and then you forget, like, you added to the 13 somehow or whatever. And then for the first few years that I taught it, I would be like, combine like terms. The 13 has an n on it. This is the one that has the number. And I did one change, and all of a sudden it went from half of them getting correct to everyone getting it correct all the time. And it's a simple little change. I feel like a salesman. All you do, when you add 4, put it in the front right here, and you will never get it wrong. So x equals 4 plus minus. You can't get it wrong now because you know now it's 4 plus that and 4 minus that. 13 over 2 pi. Our cosine of negative 4/7 plus 13n. Are we cool? So here are your two equations. These are called general equations. x1, or x subscript of 1. 4 plus 13 over 2 pi. Our cosine of negative 4/7 plus 13n. And then x2, 4, instead of plus, I'm going to do minus 13 over 2 pi, our cosine, negative 4/7 plus 13n. Are we still cool? I take my calculator, and I'm going to go ahead and type this. I want it to look verbatim. Don't worry about the 13n. That's just how often it repeats. I'm just going to type this into my calculator, that part. And I'm going to write it right here. x1 equals, let me put an arrow, because I'm running out of space here, guys. So here's my calculator. And second quit. So here's my home screen. Oh, let me clear all that. And I already forgot, was it 4? Yeah, 4 plus, make it look exactly how it is on that paper. So how do I make it look exactly? Push alpha, y equals, enter. And then you get a little fraction there, see? 13 over 2 pi. How did I get the fraction? Alpha, y equals, enter. 13 over 2 pi, arc cosine, negative 4/7. And I'm going to push enter. Oh, don't do the plus 13, because we're going to add 13 to get all the other numbers. You know what I mean? So 8.508. That should be an answer. That should be one of your answers on the top, right?
Yes.
Perfect. 8.508. So here it is. 8.508 plus 13n. So that's going to give me all of those answers. x2. Instead of a plus, you're going to do a minus. So just scroll up, enter, and then change the plus to a minus. Make sure you know the difference between minus and negative, guys. The ones on the right hand side, that's your plus, minus, subtract. And the one with the little parenthesis on it, that's a negative. Minus. Enter. So negative 0.508. That better be another answer up there as well. Negative 0.508 plus 13n. How do we feel so far? All right, we're in our last steps. X equals, and I don't see my first initial. We'll talk about that one in a little bit. Comma, then I see negative 0.508, negative 0.508. That's coming from equation 2. Comma, then I see 8.508, 8.508. That's coming from equation 1. Comma. Now to get my next one, take equation 2 and add 13. So I'm going to go to my little calculator. I'm going to push enter on that and I go plus 13. And there's my next one, 12.491. 12.491, that's coming from equation 2, comma, the next one's coming from equation 1, the 8.508. So I'm going to go scroll up, 8.508 plus 13. 21.508. 21.508. It'd be nice if they were in order. It'd be nice. And then I think I need one more. Take the 12. Well, we need two more, but 12.49 blah 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 plus 13. 25.491. Okay, so catch up to there. Notice I left a blank space there. Yes, ma'am. Yes, x1, I got it from 4 plus, and x2, I got it from 4 minus. You see how there's a plus minus right here? So on the calculator, I just went, let me scroll up. See? I just went 4 plus. And then how do you get the 13 over 2 pi? You push a little fraction. So you go 4 plus, and then alpha y equals, enter. Then you get a little fraction there. See? And then 13 over 2 pi. The pi is where the caret is at. And then our cosine. And then negative 4/7. Yeah. Why is there a blank space? After that, you just get the other one by just scrolling up and changing the plus to a minus.
So, are we going to get a number that's minus negative 1.9?
All right. Here comes the question. How come I don't have this negative 4.491? Well, because first and foremost, the calculator spit out 8.508 and negative 0.508. But can I get the negative 4.4915? Yes. You and I know that the domain is between negative 7 and 27. Yes or no?
Yes.
So if I were to take, so let's just start with the wrong one. If I were to take x2 and I were to subtract 13, I would be at negative 12.44, whatever that is. And that is outside that domain. Does that make sense? So I take x1 and I'm like, I don't have them all yet because, I take x1 and I subtract 13, and is that going to give me that number? Yeah. So let's see. There's my x1 up there. push enter, and then minus 13, and push enter again, and there it is, negative 4.491. Cool or not cool? So type that in, negative 4.491. And there it is, guys. Now zoom out. Well, I guess you guys can't zoom out because you guys are... Look at your paper. Would junior high you be scared of everything you just wrote? But now that you're here, don't you feel beast? Oh. You should feel beast. Look what you just did, guys, and you understood it. Now all it takes is practice. Practice makes progress, guys. You're not going to be a beast at this overnight. So it's just like Michael Jordan didn't just start dunking the first time he played basketball. So, cool? Yeah, like the very first time you played volleyball, were you super beast? Like already, like, oh, I played volleyball, I'm the best. No, it's taken you guys years to become the elite athlete you guys are. Because now you guys are going to state. So, how many years has it taken you guys? Have you been playing all your life? Look, you've been 10 years. 10 years also? How long have you been playing volleyball? Since you were 5 years old? So. All right.